Alright, welcome everybody. Welcome to this channel in which I will try and teach you everything there is to know about how to create your own 2D game in Unity. In this specific series, we will create a top-down game and we'll do everything using the newest stuff we can use in Unity. So specifically, I'm going to use Unity 2019, the alpha build, because there are a lot of stuff there that are very useful, just like the input system, which is very, very cool. The new input system, of course, there is an old one, but we're not going to use that because, well, we are much better than that, aren't we? So before you start, you will need to download the latest version of Unity. So right here, I'm using Unity 2019 .2.089. Anything above that is fine. Some maybe even below that maybe is fine, but I think you need at least 2019.1 in order for everything that I'm going to show in this series to work. So let's get right into business. So when you create your own new Unity project, you will see the screen. I'm assuming you already know how to use the UI. If you don't, there are plenty of tutorials about how to use the UI. If there really is a need, then I will create one, but I really doubt it. Let me know in the comments. So I'll start with the grounds up. Let's talk about how to actually input sprites into the game. Then we'll talk about how to move them. And in the next video, we'll actually see how we can create a character controller using the new input system. And slowly but surely, we'll learn even more and more cool stuff about how to create a Unity game, a 2D game in Unity. And we will cover character movements, animations, AI, and much, much more. So for this demonstration, I've requested that my girlfriend will create me this new cute koala sprite right here. It's a pixel art and it's supposed to be me, so I guess it is. Well, it must be, isn't it? And if I'll just try and drag and drop it here into the inspector or into the scene, then you will see that Unity just ignores me. Well, that's because this is just an image and we need to define it as a sprite. Well, in order to do this, we need to go to the inspector right here, and we will need to change the texture type from default to a sprite. So you need to check sprite 2D and UI right here, and then you will need to click apply. Now let's see. So I can now drag it here, which is very nice. If I'll go close, you will be able to see it in all its glory. But if you look very, very closely, you will see that it's a bit blurry. Well, this is a pixel art, so pixel art shouldn't be this blurry now, should it? Well, this is an issue with how we defined this. So we can see with all of these properties that our Koala Code import settings has, all kind of properties that tells Unity how we want to render this picture. Now, as I said, this is pixel art, and we don't want it to have any anti-aliasing, because when pictures or sprites have anti-aliasing, well, they become a little blurry. But this is a pixel art, so we will need to change the filter mode. The filter mode actually tells Unity if to use or not to use and how much to use anti-aliasing. So we'll change it from bilinear to a point, no filter. And as you can see, everything is much crispier now. Again, let me show you. So this will be trilinear, sorry. Bilinear, you won't really see any difference, especially because this is a pixel art. And point, which is a major difference. This is how it should look, right? So now we have this cute little koala bear, and if we run the game in play mode, yes, apply, thank you, and then we will see that nothing really happens. It gets rendered to the screen. Great, right? Let's use split screen so we can actually see. So let's get rid of this directional light because we really don't need it, let's be honest, and we will look at a 2D perspective. All right, so let's move the camera a bit. Yeah, so yeah. Okay, now first thing first, you will see that when I move the camera, it gets closer and further away. Now that makes a lot of sense now, doesn't it? But that's not how we want it to work, because we don't want to use a perspective projection for the camera, because we want that in a top down game, we don't want the distance of the items from the camera to change the size of them. So in order to prevent that, we will use an orthographic camera, and then no matter how close or far away the camera is, unless it's behind the item, it will always look the same size, which is exactly what we want for a top-down game. So now that we have that, if we do want to change like the size, we can actually go to the size here, then we can actually change, and you can see exactly what happens in the scene. You can understand why it changes. But now that we've changed this, let's just put it on a 5. All right, no, that's a bit far actually. Let's put it on a 3. Yeah, this looks good. Right. So now that we have our koala bear, cute koala bear right here, and we have a camera that looks at him, and everything is fine and dandy, we want to move it. Now we can obviously just click on him and move it around like so, which is very nice, but we want him to move independently of us, right? We don't want him to be controlled by the editor. Well, in order to do that, we will need to create a new script. So let's do that right now. We will create a folder and we'll call it scripts, right? And in it, we will create a new script, obviously enough. Let's call it mover. Yeah, mover is good enough, right? And let's open it. All right, so as you can see, I'm in the editor right now, and Unity has created a new file for us. It has a mover and a mono behavior. Again, if you don't know what these are, then there are plenty of tutorials out there that will teach you. But in short, a mono behavior is a class that allows the Unity editor and Unity itself to interact with your objects. So in order to actually do stuff, let's go over what is a start and what is an update methods. Well, the start, well, it does exactly that. It runs at the start of the initialization of the object. So if we want to do anything to the objects just once when it first appears, then we do it here. So let's say we want to we want the object to start at the 0, 0, 0 vector of the screen. So we will tell Unity, hey, what's going on? Transform.position, sorry for that, about that, and let's say that it will equal the 0 vector of Unity. So if I save that and I'll go back to Unity and I'll put the script over our cute koala code here, so it will have the mover script right here on the inspector on the koala bear koala code. All right, and we'll actually start the game. We will see that it teleported right into the 0 vector, as you can see, 0, 0, 0. If we change this to, let's say, a new vector, let's say 1.5.0, then if we save this and run the game again, then we will see that it will teleport, well, above the camera. So let's put it back down. All right. So that's what the start script does. It's great if you want to initialize some data, if you want some, I don't know, some configuration to run before the actual object does anything. This is what you want to do. But right now we don't need this. And all we want to do is just to move our koala bear just a bit every time the screen renders, and that's exactly what the update function does. It runs your code right here every time a render is happening, every frame of the game. So in order to actually move our panda, well, you already know that we did it just now. We call the transform, the position, and we give it a new vector. So what should we do? Let's say we want to move our koala bear 1 unit every second, right? Every frame, right? So we'll just let's say we'll use the current transfer position, right? Position.x, and we'll add just 1 to it, and then we'll use the current transform position y.y, and that runs from position .z here. And let's just introduce a variable here, because why not? This is incorrect. This should be a new vector tree. All right. Okay. Yes. All right. Sorry about this. And that's it. This is more than enough, right? So let's save and see what happens. If we run the game right now. Yep. Did you see that? The koala ran away from us. So why does that happen actually? Because this value right here, 1, is a really large one, even though it seems like it's really small. And it's really large because in every frame of the game, we will use the koala by 1 unit. So this is 1 unit, this is 1 unit, this is 1 unit, this is 1 unit, and so forth and so forth. And frames are happening really, really quickly. So we don't want it to be that quickly. So what we can do, we can just lower the number, right? We can use 0.01 f float. If we save that and we run the game again, well, it moves slower, just like we wanted it to. But there's a catch. This is not the correct way of doing stuff. And why not? Well, you see, when the games get overloaded, and this will happen from time to time, especially if you're creating a big game, the movement won't be as smooth when you're using something like that, because it's independent of the time the game actually moves around. So we want to make the movement be dependent on the time. So Unity has a very, very specific way of doing that, and it's called time.delta time. Delta time, if you go to the Unity documentation, let's do this right now together. Unity, here you go, delta time. Elevator music. All right, so the compilation time in seconds since the last frame. All right, and this is a read only. It means that we can't modify it. So that means that the delta time is a really small number, and it tells us how much time has passed since the last frame rendered. So why is this good? Because it allows us to move at a certain rate for every frame. If we have lags in the game for some reason, and we just had like 3 frames in 1 second for some reason, because we have some horrible lag because the computer just caught on fire and it just wasn't able to enter the game, we will still move the exact amount we're supposed to move per frame, and not any more than that. So how do we do this? We can use the delta time, and we need to multiply it by a certain amount, let's say by 1. So 1 times delta time, well, it will be, well, just delta time, but we'll leave it as at 1 because we want to change the speed somehow later, and we'll do that. But let's see how it will look now. Right, so we've got the same thing, but trust me, it's much smoother this way. So let's try and add a little functionality here, right? So let's say we want there to be some kind of speed. So we'll add a new property here. We'll call it speed. It will be an int type, an integer type, and let's default it to 1. The fact that I'm using a public here means that we can see it in the inspector. This is not the best way of doing this, but for now it will work, and I will show you a better way of doing it in a second. Let's replace the 1 with speed, save the game, and run. Okay, now before we run, we can see that the mover script right here now has a speed variable, which we can just change right here from the Unity editor. Let's run the game. As you can see, the koala moves. Let's change the speed from 1 to 5, and it's faster. Let's change it to -5, and it goes backward. Let's change it to 50, and it's racing to the finish line. So this is very nice, and this will be pretty much where we conclude our video. But I will show you one more thing before you leave. You might have noticed that I said that using a public modifier here is not so good, and well, the reason for that is that any other class from outside can accidentally even call and overwrite the speed here once it's public. and we don't want it, but it has to be public for Unity to be able to read it. Well, there's a better way. We can declare it private, and now no one can actually see it, but if we save it, we won't be able to access it. As you can see, it disappeared. So we want it to be private, but we still want it to be editable. So the way of doing that is, well, there's a very special and cute notation that Unity has added for us, which is a serializable field. Now this Unity reads this like notation, and it just knows that even though this is a private variable, you should be able to read it in your editor. So if we save it like so and go back and give it a few seconds to compile, and voila, we have the speed variable even though we have a private modifier for the field. And that pretty much concludes this first short video. In the next video, I will cover how to extend this mover and read input from the user, move around in all 8 directions and even more of them if you so want to, choose to, and well, do a lot of other cool stuff. Thank you all for watching. Thanks my girlfriend for this lovely panda picture, and I'll see you in the next video. If you love what I do and if you love this pixel art, you're more than welcome to follow me or my girlfriend on Twitter. I will put the links down below. Also, I will put a GitHub repository so you can actually download this code and try it for yourself. That's it. Thank you and goodbye.